So the last topic that we're going to cover in digital electronics this week is Karnaugh maps, or K-maps for short. These are a visual way of simplifying Boolean expressions. So in this case, you don't have to use algebra, and sometimes it can be an advantage. It can be a lot quicker to use K-maps, and sometimes you might also have a preference whether you calculate using algebra or whether you use a K-map. But in order to use a Karnaugh map, the expressions that you start with have to already be what's known as sum of products. Now, what do we mean by sum of products? Well, basically, your entire expression has to just be the sum of individual products. So you can't have brackets and various terms in brackets with being multiplied together within your expression, like these examples here. And you can't have a single overhead bar extending over more than one variable. So in these examples, you would first have to simplify them or expand them out in order to get these expressions, and then you could start using K-maps. So it really depends on the expression or the circuit that you're starting with, whether it's easier to just use algebra or whether you can jump straight in and use a K-map. In order to use Karnaugh mapping to simplify an expression, you first need to learn the order of the table headings. Then you go from your algebraic expression and you map that into the table. So you map it into the table, and then you have to use the rules that I'm going to upload to look for groupings of 1, 2, 4, 8, or 16 ones that are together, and you always choose the largest groups. So this is kind of complicated before you see an example, and I think the easiest way to show you how K-maps work is to just go through a few different examples. So take your time, go through the examples, and then hopefully you'll be able to understand how the rules work. These are the grouping rules for K-maps, and I'll also provide a downloadable file for the people taking this course in Maastricht. So when drawing a K-map for an expression that has just two terms in it, you need to know what the table looks like. So the headings always have to be this exactly. So you have not A, and here you have not B and B. If you get these muddled up, then when you follow the rest of the rules to solve Karnaugh maps, then you're going to get the wrong expression out. So it's really important that you get the order correct of the table headings. So in this expression, what we do now is we map these into the K-map. And what that means is we have A and B. So A and B is going to be here. So it's like a coordinate system. So that's going to give us a 1. A not B is here. So this is A and this is not B here. And this is also going to be 1 because they're the expressions. This expression Q is a 1 when A and B or A and not B are 1. So this is the expression, and anything else you fill into 0. So we've mapped our expression into the table. Now we need to look for groupings, and those groupings need to be groupings of 1, and no zeros are allowed in the group, and the groupings are either the 1, 2, 4, 8, 16, etc. Number of ones in the group. We have a group of 2 ones. So that's the fewest number of groups. We could have this is a group of 1 and this is a group of 1, but the rule is that you need the fewest number. So we have one group of 2 here, and we look at what's common. So common to both of these is A, but the not B and the B is not common, so we don't include that. The only thing that is common to this group is A. So that means that this expression is equal to A. So again, in this example, we also have an expression with just 2 terms, A's and B's. So again, our headings are going to be the same. So I have a not A, and a not B, and a B. And then I need to map into this So A and B gives me a 1 there. Not A is over here and B, so I have a 1 there. And here I have not A and not B, so that's there, and this one is a 0. So again, going back to my rules for solving these K-maps, I need to look at groupings of the ones, and I can't do a group of 3 like that. So I can do a group of 2 here. I could do a group of 1 there, but actually the rules specify that my groups have to be as big as possible and they're allowed to overlap. They're not allowed to be a diagonal, so I can't group those two together, but they're allowed to overlap. So this represents a group here, and instead of highlighting a 1 on its own, I highlight those. So I have 2 groups of 2 because of the rule that I have to use groups that are as big as possible. I'm not allowed a group of 3 because it's not a power of 2, and having groups of 1 aren't as big as possible, so I can't use those either, and I'm not allowed to group diagonally. So those are all of the rules that come into play. So now I need to look at exactly what are the expressions of these 2 groups. To do that, I look at this first group. What does it have in common? Not the B's, right? Because I have a not B and a B, but it has not A in common. And this one here has got not A and A, so it doesn't have that in common, but it's got the B's in common. So this group is represented by B. So my expression is going to be this or this. So in this K-map, you get a 1 coming out as your output function if not A or not B are ones, like this. So that's my final expression for this example.